Hello everyone, and here is question 12 from the paper 2 of of 2022 rather. So let's have a look at this question. So it says the function f is defined by f of x equals e to the 3x over 4x squared add k, where k is a positive constant. Show that f dashed of x is equal to that. So this is going to be the quotient rule. So our u is going to equal e to the 3x. So therefore, our u dashed is going to be 3 e to the 3x. Our v is equal to 4x squared add k. So therefore, v dashed is going to equal 8x. Remember, we're given the quotient rule in the formula booklet, admittedly in a different format, but it is going to be u dash v minus uv dashed over v squared. So u dashed v minus uv dashed over v squared. So let's sub into that. So my u dashed is going to be 3 e to 3x. My v is 4x squared add k. And then we're going to take away from that e to the 3x times by 8x. So we're just subbing in to that formula all over v squared, which is 4x squared add k all squared. Okay, perfect. Good. So now what can we do from here? So this is our f dashed of x. Well, from here we can take out a factor of e to the x in the numerator, or rather e to the 3x, which is going to leave us with 3 times 4x squared add k minus 8x. There we go. All over 4x squared add k all squared. And we're almost there now, actually. So let's think about this. If we expand the numerator and collect like terms, that's going to give us 12x squared minus 8x plus 3k, all over 4x squared plus k all squared. Okay, that's great. So this means that now we can write this in the form, oh, this is perfect, to show that. So 12x squared minus 8x plus 3k, which means that the g of x is e to the 3x all over 4x squared add k all squared. So that's the g of x. So we've basically got it into the required form. So therefore we can say g of x is therefore equal to e to the 3x over 4x squared add k all squared. Okay, that's the first part of our question done for 3 marks. Now part B, it says given that the curve with the equation y equals f of x has at least one stationary point, find the range of possible values of k. So if there's at least one stationary point, we're looking for f dashed of x to equal 0, okay? So what we're thinking about is, when can this equal 0? Well, we know that this expression here, we can say that g of x is not going to equal 0. And we can tell that because the numerator is an exponential, and the numerator doesn't equal 0. And the denominator is just something squared with a constant squared. So that's going to be positive. So this, we can safely say that g of x is never going to equal 0. So it says, given that it has at least one stationary point, so that's saying that this quadratic expression here must have at least one root. It's either got one root or 2 roots. So what we need to do then is we need to evaluate the discriminant, the b squared minus 4ac, as being greater than or equal to 0 in that quadratic, and consider what range of values that gives us. So let's do that now. So b squared minus 4ac is greater than or equal to 0. And let's just restate our quadratic again. It is 12x squared minus 8x plus 3k. Okay, we're going to set that equal to 0 if we're solving it. Okay, so when we sub in there, that's going to be minus 8 squared minus 4 times by a, which is 12, times by c, which is 3k, is greater than or equal to 0. So that gives us 64 minus 144k is greater than or equal to 0. Taking that over the other side, we have 64 is greater than or equal to 144k. And that gives us that k is less than or equal to 144 over 64. And that simplifies down into 4 over 9. Oops, hang on a minute. Upside down there. Turn my fraction the right way up. That is, sorry, 64 over 144. And 64 over 144 is, when we simplify that, 4 over 9. Okay, there we go. So 4 over 9. Now, let's think about that. So we're going to have that the range of values of k that we're going to have is that k has to be less than or equal to 4 over 9, but it needs to be greater than 0. Okay, that is perfect. Good, good, good. And that is going to be our range of values for k. I hope that you found that video useful, and I will see you in the next video.